With the new project opened and the AWS provider installed, we will open the provider panel, expand AWS, and we'll search for VPC. This will filter out the list and we can find the VPC resource, which we will click and drag and drop into our workspace. We will assign the VPC a name of main, a CIDR block of 10/16, and we'll add a tag of name, and we'll override the value to be a string, and we'll call it demo VPC. We can do the same for subnet. We can drag that into our workspace, select it, rename it to public AZ1, use US East 1A for the availability zone, and for the CIDR block, we'll do 10/24. We'll also add a tag to this resource of name, overwrite the value to a string, and we'll call this demo public SN1. And for the VPC ID, we'll select the chip in the middle panel, drop that into our field, and select the ID. And this will generate the HCL code for linking resources together and its dependencies. And this is the normal way in which we'll use Structura. Click and drag and drop all of the resources that you need for your project into your workspace. But we have been working on adding AI into Structura. To use the AI, we make a selection and we can add the selection to a conversation. Once we add a selection to the conversation, we are giving the AI some context behind the questions that we're going to ask. In this case, everything that I want to ask needs to affect the VPC. So the first thing I'm going to do is change the CIDR block to use a variable. And you'll see it created a variable for the CIDR block of a 10/16 for the default is what we originally had. And it's also updated the CIDR block parameter within that configuration. If we update and create, we'll see that the variable resource or variable node has been added to our workspace, and it's also updated the resource node in place. We can do something similar for the subnet. If we select the subnet and we can say change the CIDR block to use the CIDR subnet function. So that's updated the CIDR block field again. It's using the CIDR subnet function, which we asked it to, and it's selecting 0 for the index, so this will make a 10/24. We can update that node. If we open it up, we can see that it's updated again in our actual project. We can select this resource again, and let's say, can you create another subnet for US East 1B. It's created the subnet, updated the availability zone, incremented the index to 1. So now we'll have a 10/01. And we can add that to the project. Position these nodes around. Next, we'll select the VPC and we'll say create an internet gateway. So we'll create the internet gateway, link it to the VPC, and tag it using the same scheme which we have been using in our project. We'll start a new conversation using the internet gateway and the VPC in our selection, and we'll say create a route table. Next, we'll want to associate the public subnets to this route table, so we can select all three in a context and associate the subnets to the route table. This created two resources for us, which we will add to the project. If we save and run a plan, we can see that we have 7 resources to add, and the plan is looking good so far. Next, we'll ask the AI to find the latest Bitnami Nginx AMI using a data source. And everything's looking great there. We'll create that resource. Selecting this data source, we'll start a new conversation and we'll say, can you create a launch template using an instance size of T2 micro? Looks good. Add this to the project. Selecting the template, create a auto scaling group using this launch template. And now it's trying to add the VPC zone identifiers, which we did not give it context to our subnet. So we can change this, and the min and max size is kind of large for the demo. So to improve this, we can select the subnets and start a new conversation. Create an auto scaling group. And this time it gave us a desired capacity of 1, max size of 5, min size of 1. It's using our resource for the launch template and getting the latest version. And it's also added our subnets to the VPC zone identifier. We'll start another conversation using the VPC as the context, and we'll say add a security group for port 80. It's missing the egress, so we can say include the egress for all traffic. Typo there. And that's looking good. In the launch template, we will find the VPC security group IDs, and we can add that security group. Drag and drop the chip, select the ID. And in the ASG, let's just change the max size to 3. Let's double check things here. For the name, we can say AI demo. Everything else is looking good so far. Then using the ASG, we'll start another conversation, and we can say, can you add a AWS ALB for this auto scaling group? This is adding a lot that I don't necessarily want. I'm going to exclude this from the context as well as this. I'm going to say, can you create a ALB the listener and target group as resources. And that is looking good so far. The target group will need to be assigned to the auto scaling group. So target group ARNs. Add a new item, drag it into the field and select the ARN. And I want to confirm the security group. It's using the wrong name, so we'll just update that to use the one we created. Let's run a plan for now, make sure that our code is valid. We have 13 to add. And everything is looking good so far. We'll try and deploy this. We'll apply these changes. So it looks like we have a conflict of name on our auto scaling group. Let's just update that. Run the plan. We have that ASG to deploy. We will apply that change. And now it looks like everything has been created. One thing extra we could do is select the ALB in the conversation, and we can say, how do I output the DNS for this resource? And it's creating me the output node for the application load balancer. Now if we were to apply this project, we can see that the DNS name is this. And there we go. We have our load balancer, auto scaling group, and the VPC built with traffic routing to and from the internet.